I gotta just ask for. I think at Southwest, I think they've all got speakers built into the wall or in the ceiling, and then they wear microphones so it projects. I think I could use that to. So, so the one teacher that records all the lessons that uses a microphone every day doesn't have one. So, all right, thank you. Well, yep, it kind of adds to the mystique of who I am. All right, here we go. Find the volume of the area bounded between the curves x plus 2y equals 6, x equals 0, y equals 1, rotated around y equals -2. What's different about this problem? I'm not rotating around the x-axis, nor am I rotating around the y-axis. All right. All right, here we go. So I'm going to have to take up a lot of space here as I draw this. Um, So x plus 2y equals 6. As I graph this, I'm going to say that this has an x-intercept of 6 and a y-intercept of 3. Would everybody agree with that? Yeah. Everybody see how I figure out a real quick way to graph that line without... Okay. Okay, so if you plug in 0 for y, what would x be? If you plug in 0 for x, what would y be? So those are the intercepts. Nope. Nope. If you have a line like 5x plus 2y is equal to 10, then you know that the y-intercept is 5 and the x-intercept is 2. What up, G? Okay. All right. So looks like I've got that for a line. We all good? Okay. And then I've got x equals 0. Well, what's x equals 0? Y-axis and y equals 1. Horizontal line at 1. So do you see the region that's shaded that is enclosed? Okay, I'm going to draw a vertical rectangle as I'm making a vertical rotation. And then I'm rotating around what? Y equals -2. So I got that guy right there I'm rotating around. So what I'm going to try to do is I'm going to try to draw the same shape but symmetrical below that rotation piece. So how far is the base of this triangle from that axis of rotation? It's 3 units, so I'll go down 3 more. 1, 2, 3. And it looks like that's going to be bottom. And then I would have to go 2 more units, so something like that. You okay with that? So I pretend like this was like a mirror. Like you're gonna flip this guy over that. Just gonna. It's like 1, 2, 3. So 1, 2, 3. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. I just took the exact same piece that sat above that and dropped it below it. You don't have to do that. That's just to help us visually with what's going on. So I even drew my rectangle down here. So now I'm going to draw this shape. And you can see that a lot of this shape is hollow, isn't it? But part of this is solid. It's probably one of the better jobs I've done over the years of drawing this thing to scale. So I'm proud of myself today. Everybody see the shape? I know you're taking time to draw it in there. So the fact is that again, a lot of this shape is hollow. I almost picture it like a PVC pipe fitting. You know, where you got a lot of empty space. You got something going up here, some type of like flange. So with that, that's where we at. Or like just a donut. I had a donut this morning, old fashioned. There's I got two of them for 76 cents. So that was a good deal. And I keep a container of orange juice at home, so it was cheap breakfast. So anyway, that's what we've got. The difference is I know that I have this whole pi times r squared minus little r squared. Is it going to be dy or dx? How come? Because it's horizontal width of that rectangle. Because I drew a vertical rectangle, it's horizontal width. Yep. So I have this dx thing going on here. Again, this is just the way I like to do it, but I like to draw my shape just one more time. It's a real quick one. I like to put some of these pieces in here. So, what makes up the center? Y equals -2. What generates the inside of that washer? Y equals 1. What generates the top part of the washer? Right, so this line right here generates the top. Now, would we all agree that it has to have an x in it in the end? So therefore, I'm going to have y equals. So as Katie solves for this, she got y is equal to -1fx plus 3. Is everybody okay with that? So now what I need to do is I need to determine the inside of the washer. What is the radius of the inside of the washer? Can you tell me how you're getting 6? Oh, okay, I see what you're saying. Okay, so that's the diameter of the inside. So 3. Does everybody see that? So here's what's important, okay, is that when you determine the height of something or the length of something, you use one of two methods. You either do top minus bottom or you do right minus left. Okay, top minus bottom or right minus left. So to get the height of this radius right here, top minus bottom, 1 minus a -2 is +3. And then I have the large radius. So again, I take the top one, -1fx plus 3, and I subtract off -2. So that will create what constant on the end? plus 5, right? So if I subtract off a negative 2, I will add 2, and I'll have a plus 5. So when you don't have 0 for a center, it's important that you recognize that you have to subtract that in order to get the total distance. You can see from our picture here exactly why that is the case. So we've got y is equal to negative 1/2 x plus 5. That means that the area, or the volume of this piece is the integral of negative 1/2 x plus 5 quantity squared minus 3 squared dx times pi. That is going to be the volume of one washer. How many washers do we want? So I slap the integral in front, and then I'm going to integrate. What are my bounds? Anybody? It is 0 to 4. Hold on. Mr. Braden? Because I have to do the top minus the bottom. If you take this guy minus it, just like we did for the radius on the inside, we did 1 minus negative 2 to get 3, right? So you do top minus bottom here. Better? Okay. So Grace asked a question about the bounds. If you look at the original area, which is right here, everybody see this area? So what I have y values, which I'm not concerned about because it's not dy. It says dx. So therefore, I need to be concerned about these values. Well, you can see that I start at 0, and I go all the way to that point right there. Well, that would be the intersection between y equals 1 and this line right here. And if you would plug in 1 for y, you could see that x is 4. Or if you make a really good drawing, you can see that it's 4 as well. Question? No. But I will say that the majority time on the AP exam, they give the drawing for you. You do not have to come up with it on your own, the majority of the time. If you, yeah, so you know that it's the intersection between y equals 1 and that, right? So if I plug in 1 for y, I have x plus 2 is equal to 6. So therefore, my x value is 4. Okay. All right. That was the tough work. Now let's just integrate. Pi times integral 0 to 4. Negative 1/2 x squared, 1/4 x squared. Yeah, we're going to have a negative 5/2 x and another negative 5/2 x, which is going to make a negative 5x. Plus the 25, and then I can subtract off the 9, can't I? So I get plus 16. Antiderivative of 1/4 x squared. If I plug in 0, I get 0. So I just have pi times 4 to the third is 64. And 64 divided by 12, 16 thirds, minus 4 squared is 16 times 5 is 80, and 80 divided by 2, 40, and 16 times 4, 64. So I have negative 40 and 64 make 24. So pi times 16 thirds plus 72 thirds, and I get 88 pi over 3. The answer is always beautiful, isn't it? Good job. Take out your calculator. Let's look at a perfect example of an AP question. I want you right now, between you and another person, or a group of 2 or 3, or cluster of 4, however you work it, I would like you to try to do problem A from this AP question on your own. Use your calculator. You have to use your calculator. See what you can come up with. Go. Okay, let's pull together and pause where you're at and see what we can get here. What is this location right here? Okay, 0 is the x value. Did you come up with the y value? Okay. You don't have to have it, though, do you? And you don't have to have it because you don't have to draw horizontal rectangles. You get to draw vertical rectangles. So you can see right away that this problem is definitely a dx situation. We all agreed? Did you come up with this intersection right here? What is it? All right. So what I'm going to do is I'm going to call that A, and then I'm going to say, well, we'll just say that this is 0, okay? So we've got that. Great. So if I want to find the area of R, I would have the integral from 0 to A of, what's the top function? Yep, and I'll just write f of x minus, what's the bottom function? G of x dx. You forget the dx, you forget the bound, you forget anything like that, they're going to take points off on the AP exam. Just for writing that, you probably get 2 points, folks. No, you may not. You may not. You may not on the AP exam. You may not, by any means, just simply shoot down your answers. You must set up the integrals. You must show how you generated your work. It is free response. They want to see your mathematical reasoning, hands down. So they want to see the integral sign. They want to see the dx. They want to see the 0. They want to see the a. Yep. Good question. How did you guys find a? Okay, yeah. So if we go with that calculator, which I'll do right now because I'm going to use it anyway, because we can wait for this to pop up. Anybody watch? Is it called Free Solo? Yeah. Guy who climbs a 3,000-foot side of a mountain in Yosemite, and he uses 0 safety precautions. Now he's done it many times before, but he's always had safety gear on. But so yeah. So if you haven't seen Meru, great documentary, amazing, and Free Solo. Yep, be ready for it. Um, it's a good watch. So anyway, all right. Yeah, I think that's where my wife and I caught it, National Geographic. So, all right. So as I turn it on, I go into my y equals, and I'm going to clear these guys out, and I've got 1 plus sine of 2x. And make sure I'm working in radians. And then I've also got e to the x over 2. Is that what we have? So e to the x divided by 2. And I'm going to zoom standard, zoom 6. And it looks like this is the little region right there. It's very tough to see, so I'm going to zoom in. Actually, what I'm going to do is I'm going to zoom as a box. You can see as I zoom as a box, I get the shape. I saw Riley kind of come up with the same type of piece, so I knew I was on the right track if Riley was doing it right. So that was good news. If you want to check the 0, you sure can. I'm pretty confident in that. Second, calculate, and we do number 5, intersect. And I just make sure that I'm closer to that intersection point than the other intersection point. Enter on the first curve, enter on the second, enter overall, and then we come up with a 1.13569. Yeah, your calculator is extremely powerful. Everybody good there? Okay, then I actually have to calculate this. And so now that I have this in my calculator, what I'm going to do is I'm going to go y equals, I'm going to take that guy off and that guy off. I'm going to go down here, and I'm going to do bars, y1 minus bars, y bars. Whoop. Thank you for reminding me. There I go. I've got the y1 minus the y2. I go ahead and I calculate number 7. It obviously gives me a different look because I have two functions together now. I go from 0 to 1.13569. Should be good enough. And on the AP Calc exam, there are, in this situation, only one answer that'll be acceptable, 0.429. If you simply just cut off to 3 decimal places, you're fine. Okay, question. Save time writing, because I wrote it down once. I'm confident with it. As I write it down more and more and more, there's a chance I would make a mistake. If I accidentally wrote 1.14 down, they would mark it wrong. Yes, you could. I just did save time. That's it. Nope, you could just write the f of x and g of x. They're already listed for you. Question. That's fine. 0.4291 is fine. You have to list at least 3 decimal places. We all okay with that? No. Oh, it's me telling you now. We all good? Okay, so we've got, that's A, here's B. We're going to do it together. Find the volume of the solid generated when R is revolved around the x-axis. I'm going to take this guy and revolve it around the x-axis. What's going to happen when I revolve it around the x-axis? I'm going to get a washer. Love it when I check people's work and I see them actually drawing the washer out. And the people grading the AP exams, they are people just like me. They are math teachers. And they're teaching it the same way. And they want to see that you're that you're doing this as well. Because they want to give you points, folks. But sometimes people just take shortcuts and don't communicate. Well, it looks like the axis of rotation is x equals 0. What makes up the inside of the washer? G of x. What makes up the outside of the washer? F of x. What is my formula for the volume of a washer? dx or dy? dx. So therefore, in order to determine this volume, I set up the integral times pi from 0 to a of big R squared. Which one is big R? F of x. So f of x, quantity squared, minus g of x, quantity squared, dx. That's another 3 points. 6 out of 9 without even doing the last one. Well, we got to come up with the right answer. I mean, you guys see how, I mean, I'm not saying it's a piece of cake, but that's all stuff we can do, right? Yeah, I think so. A little bit of practice. So let's calculate this. I go into y equals, and I'm going to change this. Instead of y sub 1, I have to have y sub 1. So I'm going to insert a squared. You can. Y sub 1 squared minus y sub 2 squared. And you'll see if you catch where we're headed here. We got y sub 1 squared minus y sub 2 squared. And now I need to do the integral so I can calculate number 7. My get a different shape because, again, it's a different deal I got going on. And I go from 0 to 1 point. Somebody help me out. 6, 9. We'll stop there. And I press enter. And I get 1.358089. Yes? Exactly. The number of times I've done that, and I did not put pi in my answer. You're fine. You could put it like that. You could take 1.358089, and you can multiply it by pi. And so in this situation, you could have 4.266, or you could write 4.267. Either answer would be acceptable. You can either round to the nearest third decimal, or you can cut off after the third decimal. Yes. Yeah, you could cut off 1.358 pi. Yep. But those are all acceptable. See it? Okay. Good work today.